Good morning, dear students. My name is Padmaraj Pandit, and I'm working as physics lecturer in Government Hanmant Benne BU College, Nellikeri, Kumta. Today, I'm going to deal third chapter. Name of the chapter is Motion in Straight Line. Let me write chapter name from this end. Motion in straight line. Okay, you have already studied chapter number 1 and 2. Chapter number 1 is physical world, whereas chapter number 2 is, of course, units and measurements. Correct? Fine. This is chapter number 3, where we have to study one of the basic concepts in physics. Chapter number one is just introduction to physics. Introduction to physics. Chapter number 2 is very important. It's important as we have to use those units throughout our journey in science stream. This is chapter number 3, where actually we start syllabus or chapters. Content of the first year. Best thing. Name of the chapter is Motion in Straight Line. And as I said earlier, here we are studying one of the most basic concepts in physics, so-called motion. ಇಲ್ಲಿ ನಾವು ಭೌತಶಾಸ್ತ್ರದ ಒಂದು ಅತ್ಯಂತ ಏನಂತ ಹೇಳ್ತಾರೆ ದಿನನಿತ್ಯ ಕಾಣುವ ಒಂದು ವಿದ್ಯಮಾನವನ್ನು ಅಭ್ಯಾಸ ಮಾಡ್ತೇವೆ. ದಿನನಿತ್ಯ ಕಾಣುವ ನಮ್ಮ ಸುತ್ತಮುತ್ತಲ ದಿನನಿತ್ಯ ಕಾಣುವ ವಿದ್ಯಮಾನವನ್ನು ಅಭ್ಯಾಸ ಮಾಡ್ತೇವೆ. ಆ ವಿದ್ಯಮಾನಕ್ಕೆ ಮೋಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಇಟ್ಸ್ ಕಾಲ್ಡ್ ಮೋಷನ್. ಇನ್ ಕನ್ನಡ ಮೋಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಚಲನೆ. ಕನ್ನಡದಲ್ಲಿ ಏನು ಹೇಳ್ತಾರೆ? ಚಲನೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಚಲನೆ ಅನ್ನೋ ಶಬ್ದವನ್ನು ಎಲ್ಲಿ ಕೇಳಿದ್ದೀರಿ? ಬಹುಶಃ ನೀವು 6th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಇದ್ದಾಗ, ಬಹುಶಃ ನೀವು 6th ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಶುರುವಾಗಿದೆ ಈ ಚಲನೆ. 7th ಓದಿದ್ದೀರಿ, 8th ಓದಿದ್ದೀರಿ, 9th ಓದಿದ್ದೀರಿ, 10th ಓದಿದ್ದೀರಿ. ಮೋಷನ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ ಫಿಸಿಕ್ಸ್. ಚಲನೆ ಅಂದ್ರೆ ಏನು? ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೋದು, ಕಾಲದೊಂದಿಗೆ ವಸ್ತುವಿನ ಸ್ಥಾನಪಲ್ಲಟವನ್ನು ಚಲನೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಏನು ಹೇಳ್ತಾರೆ? ಕಾಲದೊಂದಿಗೆ ವಸ್ತುವಿನ ಸ್ಥಾನಪಲ್ಲಟವನ್ನು ಚಲನೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಚೇಂಜ್ ಇನ್ ಪೊಸಿಷನ್ ಆಫ್ ಎನ್ ಆಬ್ಜೆಕ್ಟ್. ಆಬ್ಜೆಕ್ಟ್ ಅಂದ್ರೆ ವಸ್ತು. ಚೇಂಜ್ ಇನ್ ಪೊಸಿಷನ್ ಆಫ್ ಎನ್ ಆಬ್ಜೆಕ್ಟ್ ವಿತ್ ರಿಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಮೋಷನ್. ವೆರಿ ಸಿಂಪಲ್. Yes, what I said? Change. Let us consider an object, say A, okay, on a straight highway, straight path, ground, whatever it may be. This object is moving. How? It's changing its path. After t is equal to 1 second, this is the new position. X is the new position of your object A. After t is equal to 2 seconds, your Y represent one more new position of A. Here we observe there is change in position of an object with respect to time. Please remember, time is very important parameter when defining motion. ಸಮಯವನ್ನು ಹೇಳುವಾಗ, ಚಲನೆಯನ್ನು ಹೇಳುವಾಗ ಸಮಯ ತುಂಬಾ ಮುಖ್ಯವಾದ ಪ್ಯಾರಾಮೀಟರ್ ಆಗಿದೆ. ಟೈಮ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಟು ಡಿಫೈನ್ ವಾಟ್ ಮೋಷನ್. ನಾವೇನೆಲ್ಲ ಮೋಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೇವೆ? We observe motion of vehicles in a highway, bus, car, bike, a bird flying, a boy running, a boy cycling, we walking in a straight path. When we are sleeping, then even we just breathe air in and out. Blood flowing inside our body continuously. Flow of air, flow of water current, water flow. Earth rotates in 24 hours. It revolves around the sun within 1 year. Sun is also moving. Sun is also moving. Our galaxy, Milky Way, is also in motion with its local galaxies. So to say, in universe, everything is in motion. That's the point. In our chapter number 3, first sentence is motion is common to everything in universe. In universe, there is no concept called stagnant, stationary, rest. Everything is moving. We are in motion. That's the continuous motion. Yes. But see, this is chalk box. I will place this chalk box on this layers table. Now you can say, I am moving, correct? I am moving. As compared to me, this object is at rest. There is one more state of object then called rest. A object, a body may be in state of motion or may be in state of rest. How to define rest? How you say body is at rest? Very simple. If position of body, say A, is not changing with respect to time, then we say this object is not at all moving, it is at rest. Hope you understand. ಒಂದು ವೇಳೆ ಸ್ಥಾನದೊಂದಿಗೆ ಸಮಯದೊಂದಿಗೆ ವಸ್ತುವಿನ ಸ್ಥಾನದಲ್ಲಿ ಬದಲಾವಣೆ ಆಗದೇ ಇದ್ರೆ ಖಂಡಿತವಾಗಿ ನಾವೇನು ಹೇಳ್ತೇವೆ ಇಟ್ ಇಸ್ ಅಟ್ ರೆಸ್ಟ್. ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಅಟ್ ರೆಸ್ಟ್. A body is said to be in motion when its position changes. What is position? Let us discuss. With respect to time, a body is said to be at rest when its position not changing with respect to time. You may ask question now. So just before you said everything is in universe is moving, but how come this is at rest? Okay. Let's take an example. Imagine you are sitting in your classroom. Sitting. So you are at rest. If you look around, look outside, you observe vehicles are moving nearby. A bus is moving, a car is moving, a bike is moving, and you say, see, those things are moving, I am at rest. What? Those things, those vehicles are moving, I am at rest. Is it true? Yes, it's true. But your point of view, it's right. But your point of view, you are right. Let me repeat the example. You are sitting in a classroom and looking outside, and you observe some bus is moving, some car is passing nearby, and you say, I am at rest, those objects are moving. Fine? Now, just imagine a person on Mars, Mangala Graha, or Moon, who is sitting with very powerful telescope and observing you, observing your class, observing whole scenario where bus is moving, your classroom ending. According to him, he says, see, That bus is moving, fine. This classroom is also moving. That girl or boy is also moving. How? Why? Because earth itself moving. From that distance, we can see motion of earth. Hope you understand. At the same time, you are at rest according to your will. You are moving according to his point of view. Remember, conclusion of the concept is this motion or rest or relative terms. A body at rest, as you feel, a body, it appears to be at rest for you, may not be to the others. ನಿಮಗೆ ಒಂದು ವಸ್ತು ನಿಶ್ಚಲವಾಗಿದೆ ಅಂತ ಅನಿಸ್ಬೋದು, ಆದರೆ ಬೇರೆಯವರ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ನೋಡುವಾಗ ಅದು ನಿಶ್ಚಲವಾಗದೇ ಇಲ್ಲ. ಏನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ? ಮತ್ತೊಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ತೆಗೆದುಕೊಳ್ಳೋಣ. ಇಮ್ಯಾಜಿನ್ ಯು ಆರ್ ಟ್ರಾವೆಲಿಂಗ್ ಇನ್ ಎ ಬಸ್ with your co-passengers, co-fellow passengers. If you look at your passengers, you definitely say that passenger is at rest. Passenger B is also at rest. Why? Why? Because the distance between you and that passenger, the distance between you and this passenger is same. You people are not moving according to your friend. A person standing outside, looking whole situation, your bus, your driver, everything, feels you people are moving, both are moving. At the same time, you are at rest according to one person and you are moving according to other person. Your motion is relative, rest is relative. You have to define motion with respect to other object. We have to define rest with respect to other object. Keep in mind, your motion and rest are not absolute. They are relative. We have to express them with respect to other objects. Okay? This is a minor, just introduction to the chapter. In this chapter, we have two parts. First part is motion, and second part is in straight line. Now you are familiar with what's the meaning of motion. Why is it straight line then? Why it called straight line? Okay, let's discuss. Okay, there is okay. We know a body is said to be in a motion if its position changes. We use the term position, sthana. How to identify this position? You may say, near bus stand, I saw a train or a bus moving. Near railway station, I saw a train moving, a bird flying. In a closed container, gas molecules are randomly moving here and there. To explain this event of motion as an event or a motion, we need some standards. What standard we use to represent, measure, or to observe motion? We use a rectangular coordinate system. A rectangular coordinate system. What is rectangular coordinate system? Simple. You know, this is x dash axis. This is y dash axis. Correct? While your high school, during your high school time, while studying graphs, you know this. This is y axis, this is x axis. We consider one more axis here. That is so called z axis. It is so called z axis. Say somewhere here, this is z axis. Z axis. How? Let me show you. See, here I have two pens, correct? This is your y axis. Let me put it. This is your x axis. You have one more axis here, which is like this. Visible? Z axis. Why we need three axes? Remember, things around us are three-dimensional. Things around us are three-dimensional. In nature, we have three dimensions. You know, three-dimensional. To represent the position of an object, we need three coordinates, namely x, y, z. To represent the position of an object, we need three coordinates, x, y, and z. Correct? Okay. Let me take only two axes first. I will explain it. If you understand, then you can definitely we can extend our idea to three coordinate system. See, this is a point. This point represents a position of a body, an object. How to represent this? Very simple. This is y coordinate. This is x coordinate. This is xy. Position of this point is xy. We know this. So, this is a plane, this board itself is a plane. To represent in a plane, we need two perpendicular axes. Remember, this x-axis, y-axis and z-axis are mutually perpendicular to each other. To represent an object in plane, we need any two axis. One x-axis, one y-axis. Maybe z-axis can be take any two. To represent position of an object in space, we need three mutually perpendicular axes: x-axis, y-axis, z-axis. Say somewhere there is z-axis, z. Okay. Now, if this is a position, then it will be x, y, z. Very simple. Correct now? We have to represent a motion, to represent the position of a body, we need certain system. The best system is this Cartesian coordinate system. It's called Cartesian rectangular coordinate system. This is point O, where three perpendicular axes meet, called O, origin. From this point, we can we take this point as a standard point to represent, to express motion. We take O as a reference point. Depending on the situation, you can choose for one axis, simply x-axis, x-axis, y-dash axis, or z axis, or two axes, x and y, or three axes, x, y, and z. O is a origin. It is a reference point. I will explain. Listen. Imagine a body is moving. These are different positions of objects with the different intervals. Time t is 1, t2, t3. To represent such motion, see, we simply need any one axis, either x-axis or y-axis or z-axis, any one axis. If body is moving in a straight line, then only one axis is Here somewhere 0. This is x. This is x dash. With O as a origin. If body is moving like this, it is zigzag motion. To represent position of an object at different intervals, ಒಂದು ವಸ್ತುವಿನ ಸ್ಥಾನವನ್ನು ಗುರುತು ಮಾಡೋದಕ್ಕೆ now we definitely need this graph, this coordinate system, 1y, 1x. This will be xy, this will be xy, this will be xy. Hope you understand. Now it's quite easy to represent position with the help of graph. Imagine your object is in space. This is called a plane. This is called plane. 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 Now in space, position of aeroplane, position of gas molecule, position of bird. How to represent it? We need 3 coordinate systems there. X-axis, Y-axis and Z-axis. Depending on the situation, what we have to do? We have to select a particular origin O as a reference point. It's standard. It's a standard method to represent motion. You have to understand this. This is standard method. We need some system. The best system is rectangular coordinate system. If your body is moving in a straight line without variation, only one axis is needed, either x, either y or z. Only one axis enough. If your body is moving in a plane, like this zigzag motion, or a ball is thrown in space, a towel is thrown, shot put is thrown, simply your projectile motion or circular motion, then you need 2 coordinates, x and y. If your body is in space, in space, then you need 3 coordinate system. This coordinate system, x, y, z, with a clock attached, I will tell you. This is y, this is x, this is z. This is reference point. We can define, measure, observe your motion with O as a reference point. Condition is, this system must be associated with a clock. If a clock is attached in this coordinate system, then this whole setup is called frame of reference. Frame of reference. Frame of reference. Frame of reference is a place from where you are measuring or observing the motion. Frame of reference is a place from where you are measuring or observing the motion. In this frame, we set up a coordinate system attached with a clock. Why clock? Without motion, without time, it's almost impossible to explain neatly your concept of motion. Hope you understood. Correct. ಒಂದು ವ್ಯವಸ್ಥೆ ಬೇಕಂದ್ರೆ ಈ ವ್ಯವಸ್ಥೆಯನ್ನು ಮಾಡ್ಕೊಂಡಿದ್ದೇವೆ. ಈ ವ್ಯವಸ್ಥೆಯಲ್ಲಿ ನಾವೇನು ಮಾಡಬಹುದು? ವಸ್ತುವಿನ ಸ್ಥಾನವನ್ನು ಗುರುತಿಸಬಹುದು. ಈ ವಸ್ತುವಿನ ಸ್ಥಾನ ಜೊತೆಗೆ ಒಂದು ಕ್ಲಾಕ್ ಅನ್ನು ಹಾಕಿಬಿಟ್ರೆ we can definitely measure or observe motion. This is so called frame of reference. What is frame of reference actually? It is the frame or place from where you are observing motion. ಯಾವ ಸ್ಥಳದಿಂದ ನೀವು ಇದನ್ನು ನೋಡ್ತಿದ್ದೀರಿ, ಏನು ಯಾವುದನ್ನ ಮೋಷನ್ ಅನ್ನು ಅಳತೆ ಮಾಡೋಕೆ ಸಾಧ್ಯ, ನಿಮಗೆ ನೋಡೋದಕ್ಕೆ ಸಾಧ್ಯ, ಅದಕ್ಕೆ ಫ್ರೇಮ್ ಆಫ್ ರೆಫರೆನ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಒಂಚೂರು ಕೇಳಿ ಫ್ರೇಮ್ ಆಫ್ ರೆಫರೆನ್ಸ್. This is the best example I feel. Ground, a car visible. A plane, aeroplane. You are standing somewhere there. You want to measure motion. This plane is moving in this direction. Just imagine. With the velocity of or speed of, what is speed velocity? Let us study next. Anyway, just remember Vega, Java. These are concepts to be studied. 250 meter per second. Okay? Okay. I will change direction of this car. This car is going in this direction with velocity of 50 meter per second. If you are an observer, here a frame of reference can be attached to the ground. A frame of reference attached to the ground. Now, ground and standard frame of reference or myself. I can take myself as a frame of reference. Place from where I observe what motion. Here, your ground is frame of reference. Frame of reference means the place, the frame from where I am observing that motion. Now your ground is a frame. You can set up here a coordinate system and attach a clock. Definitely your frame of reference is ready. Now you can measure your whatever quantity you want. Displacement, velocity, acceleration of these two objects, moving objects. You are stationary observer here. You are at rest. You are not moving. Of course, you feel your ground is not moving while standing on ground. Of course, you feel the ground is not moving. So you are stationary. You are stationary observer on ground. According to you, this is a scenario. What scenario? This is a car which is moving in this direction, say left with 50 meter per second. This is a plane which is moving right with 250 meter per second. Very high. This is according to frame attached to the ground. ನಿಮಗೆ ಅಥವಾ ಗ್ರೌಂಡ್ಗೆ ಫ್ರೇಮ್ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? Just I am explaining what is frame of reference, that's all. Now, case 2. But just imagine this is a plane. Now, let me shift frame of reference to your car. Now, car is frame of reference. What is frame of reference? We are trying to understand this. Your car is frame of reference. With respect to car, you are at rest now. With respect to car, you are at rest. Now, car is at rest. In this frame, as car as a frame of reference, it is at rest, it is stationary. Now, in this frame, while sitting in a car and you look outside, you observe trees are moving opposite to your direction, correct? If you feel a frame of reference in itself in car, then the speed of car is 0, What about the speed of ground? Speed of ground is, of course, 15 meter per second to opposite direction. Try to understand. It is in opposite direction. Why? We observe, we are stationary, and things are moving like this fast. Electric pole, trees are moving opposite to us. In this frame of reference, the velocity or speed of ground is in opposite direction, 50 meter per second. What about this velocity of plane? Remember, in this frame of reference, velocity or speed, whatever it may be, your aeroplane will be 250 plus 50 is equal to 300 meter per second. There is an addition of the velocities. We'll study this in a concept called relative motion. But remember, my concept is to make you understand what is the reference, a frame of reference. If you consider car as a frame of reference, then it is stationary, but ground is going in opposite direction. Why? You have changed your reference. Now your ground is going in opposite direction. Of course, we observe. If you see outside, you observe ground is going like this. And velocity of the aeroplane will be 250 plus velocity of this car 300 meter per second. Hope you understand. Why here 300? We will study last part of this chapter. But remember, if it is stationary, in this frame, velocity of the object will change. Things will change if you change the frame. Things will change if things change the frame. Definitely, it's not very important from exam point of view. Once again, let me tell you, not exam point of view, but being a science student, what you have to understand these things. Now, let us change the scenario now. Let us consider. Okay. Same plane. Let us change what? Frame of reference. Now you are sitting in a plane, and plane is moving, of course, 250 meter per second towards right. And now your frame of reference is plane. So you are at station. You are not moving now. With respect to plane, of course you are not moving. In this frame of reference, you observe your earth will move, correct? If you are moving like this, earth will move in this direction. Your earth will move 250 meter per second in this direction. Okay? What about this car? Velocity of this car with respect to this. Velocity of car with respect to that frame, that object will be 250 plus 50, which is equal to 300 meter per second. Hope you understood. It's moving like this. Its velocity will be, you are stationary observer. For you feel it's moving 300 meter per second. Okay? Your ground is moving 250 meter per second. Here, if you are watching the whole event of motion with respect to ground, considering frame of reference as a ground, then usually it's 250 meter per second, it's 50 meter per second. If you change the frame, things will change. If you take a car as a frame of reference, then your ground will move in the opposite direction with 50 meter per second, which was the earlier speed of car. And your plane will move with 300 meter per second with addition to the car. As I told, we will understand it later. But try to understand the thing. What is the meaning of frame of reference? Okay? If you take plane itself as a frame of reference, definitely your earth will or ground will move in opposite direction with the speed 250 meter per second, which was early what speed of your plane, and your car wheel seems to be moving 300 per meter per second. We usually take Earth and ground as a standard frame of reference unless stated. ಎಲ್ಲಿ ತನಕ ನಮ್ಗೆ ಅದ್ರ ಬಗ್ಗೆ ಹೇಳೋದಿಲ್ವೋ ಅಲ್ಲಿ ತನಕ ನಾವೇನು ಮಾಡ್ತೇವೆ, ಯಾವ ಕರೆಕ್ಟ್ ಆಗಿ ಹೇಳದೇ ಇದ್ರೆ ಅರ್ಥನೇ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ತೆಗೆದುಕೊಳ್ತೇವೆ. ಲೆಟ್ ಅಸ್ ಟೇಕ್ ground as frame of reference. In this frame of reference, we have to consider a coordinate system with the origin O to represent a position and a clock to represent change of position with respect to time. This is needed to what? Describe motion. Just information, okay? Fine. Now, here in this chapter, we usually consider a point object. What is point object? Of course, size of object is point size. How come point size? Remember, let's have, we have to have some approximations. ಒಂದು ಊಹೆ ಮಾಡ್ಕೊಳ್ಬೇಕು, approximation ಮಾಡ್ಕೊಳ್ಬೇಕು. ಏನು? If the size of object is negligible as compared to distance covered by object, then we can treat that object as a point object. Let me repeat. ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ತೀನಿ ಕೇಳಿ. ಕನ್ನಡದಲ್ಲಿ ನಾವು ಒಂದು ವಸ್ತುವನ್ನ ಪಾಯಿಂಟ್ ಆಬ್ಜೆಕ್ಟ್ ಆಗಿ ತೆಗೆದುಕೊಳ್ಳಬಹುದು. ಒಂದು ವಸ್ತು ಅಂದ್ರೆ ಏನು? ನೀವಾಗಿರ್ಬೋದು, ನಾನಾಗಿರ್ಬೋದು, ಬಸ್ ಆಗಿರ್ಬೋದು, ಏರೋಪ್ಲೇನ್ ಆಗಿರ್ಬೋದು, ಭೂಮಿನೇ ಆಗಿರ್ಬೋದು. ಇವುಗಳನ್ನ ನೀವು ಪಾಯಿಂಟ್ ಆಬ್ಜೆಕ್ಟ್ ಆಗಿ ತೆಗೆದುಕೊಳ್ಳಬಹುದು. ಯಾವಾಗ ಅವುಗಳ ಚಲಿಸುವ ದೂರಕ್ಕೆ ಹೋಲಿಸಿದಾಗ ಅವುಗಳ ಸೈಜ್ ತುಂಬಾ ಕಡಿಮೆ ಆದರೆ, ಒಂದು ವಸ್ತುವಿನ ಚಲಿಸುವ ದೂರಕ್ಕೆ ಹೋಲಿಸಿದಾಗ ಅವುಗಳ ಸೈಜ್ ತುಂಬಾ ಕಡಿಮೆ ಅನಿಸಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದಮ್ ಆಸ್ ಅ ಪಾಯಿಂಟ್ ಆಬ್ಜೆಕ್ಟ್. ಎ ಬಸ್ ಈಸ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ A to B. Okay, I am talking about bus. A to B. The distance traveled by this bus is 100 kilometer. As distance is very, it's 100 kilometer. As distance between A and B is 100 kilometer, and your bus travels 100 kilometer, you can consider your bus as a point object. Hope you understand. You are walking from your home to school nearly 2 kilometers to reach the school or college. If you are walking 2 kilometers from your home to college, then you can be considered as point object. ನಿಮ್ಮನ್ನು ನಾವೇನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು? ಪಾಯಿಂಟ್ ಆಬ್ಜೆಕ್ಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಒಂದು ಏರೋಪ್ಲೇನ್ ಎರಡು ದೇಶಗಳ ಮಧ್ಯೆ 3000 ಕಿಲೋಮೀಟರ್ ಹೋಗುತ್ತೆ. Then compared to its distance, you can consider your aeroplane as a point object. As in our solar system, Earth has to revolve around Sun, you can consider Earth as a point object. In our universe, we can consider our Sun as a point object. This is the basic concept in this chapter. We have to remember point object. Okay. If distance is more as compared to size of the object, you can consider that object as point object. One more thing. Next, let me explain some of the things which are not really important for exam point of view. They are not really important from exam point of view. Just as information, the branch of physics which deals with these things means motion of an object at rest, is called mechanics. Mechanics is a branch of physics which deals with study of objects either in motion or in rest. Of course, under action of force is there, we leave that part. Let me repeat. Mechanics is one of the basic concept, basic branch of science, physics, where we have to study objects either in motion or in rest. This mechanics broadly classified into two major parts. One is statics, next one is dynamics. Statics and dynamics. Okay? What is statics? One second. Chalk piece. Okay, I'm back. Somewhere here, yes. Dynamics. What is statics? Of course, statics is a branch of mechanics which deals with object at rest. Statics means rest. It deals with what? It's a branch of mechanics which deals with study of objects at rest. Of course, some direction of force is there once again. What is dynamics? Dynamics is branch of mechanics which deals with study of objects in motion. Dynamics is the branch of mechanics which deals with study of objects in motion. ವಸ್ತುಗಳು ಚಲಿಸುತ್ತಿರುವ ಬಗ್ಗೆ ಅಭ್ಯಾಸ ಮಾಡುವ ಮೆಕ್ಯಾನಿಕ್ಸ್ ನ ಬ್ರಾಂಚ್ ಅಂತ ಹೇಳ್ತೇವೆ ನಾವು ಡೈನಾಮಿಕ್ಸ್ ಅಂತ ಹೇಳ್ತೇವೆ. This dynamics once again is seen, right? We divide into two parts. First one is called kinematics and second one is visible, right? Kinetics. First part is called kinematics and second part is called kinetics. What is kinematics? We are studying this chapter in kinematics. Motion in straight line, chapter number 3, and motion in two dimension, chapter number 4. Chapter number 3 and 4 are under kinematics. Chapter number 5 onwards, those chapters are in kinetics. What is kinematics? Somewhere here I write kinematics. Kinematics. Kine means motion. Once again, this term has two parts. Kinematics has two parts. Kine means motion. Matics means mathematics. Kine means motion. Matics means mathematics. It is a mathematics involved in motion. The study of mathematics involved in motion, like equations of motion. In this chapter, we have to study equations of motion. You already studied in your high schools. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Such things we have studied. In this chapter, we have to study motion in the form of mathematical form also. That's why it is called kinematics. Kinematics is a branch of physics which deals with the study of motion without considering cause for motion. ಭೌತಶಾಸ್ತ್ರದ ಯಾವ ಶಾಖೆ ಚಲನೆ ಬಗ್ಗೆ ಮಾತ್ರ ಅಭ್ಯಾಸವನ್ನು ಮಾಡಿ ಚಲನೆಗೆ ಕಾರಣವಾದ ಅಂಶಗಳನ್ನು ಅಭ್ಯಾಸ ಮಾಡುವುದಿಲ್ಲವೋ ಅದಕ್ಕೆ ಕೈನೆಮೆಟಿಕ್ಸ್ ಅಂತ ಕರೀತಾರೆ. Kinematics is a branch of your mechanics where you have to study motion of an object, motion of body without considering cause for it.